All right, so I'm going to only go through number 61, and then I'll go through number 62. All right, for these groups before we move on. All right, so now from here, the directions for this say to complete the square. So I chose 61 to go over for a reason, but I just wanted to talk about one thing first that you must do that wouldn't be done in this one. The first thing that you always do is when you're completing the squares, you don't set it equal to 0. You actually set it equal to the constant. So I would subtract over 27 and 60. It's already set equal to the constant here, so I don't need to do that. However, when you're completing the square, we need the number in front of our x squared to be 1. So I need to always look to factor out whatever is in front of the x squared if there's something there. So I factor out the 2, and it divides evenly into the 12, and I can factor that out. Once I factor it out, then I'm going to divide both sides to get rid of that number on the left-hand side. And I'm left with x squared minus 6x is equal to 1. All right, then, now we need to start the process of completing the square. So the whole point of completing the square is to get a perfect trinomial square that we can factor. Remember, when we complete the square, we want to factor into a binomial square. So what we do is we take our b, the number in front of the x, that's negative 6. We divide it by 2. And then we square it. We add that to one side, so x squared minus 6x plus 9. And what we do to one side, we always have to do to the other. Right? When we're solving it like we are now, we do add it to both sides of the equation. Before, when we were using completing the square to graph, we weren't solving it, so that's when we had to do the plus and minus because we were doing it to one side. Right? Now, as I said up here, it's going to always factor into a binomial square. So I can right away, after I complete the square, I can put a parentheses square. 1 plus 9 is 10. And then whatever the square root of the x squared and 9 is, x and 3. And then whatever sign we have in the middle will be the sign that goes here. And now we take the square root to solve. So we get x minus 3 is equal to plus or minus the square root of 10. And then the very last step is we isolate the x as solve for it. So we add over 3. X is equal to 3 plus or minus the square root of 10. All right, that is the answer to number 61. All right, I'm going to pause this so I can go ahead and erase all this. All right, now the next problem I'm going to do is this number 62, where your s is solved by using quadratic formula. You will be given this on your test. It's negative b plus or minus the square root of b squared minus 4ac all over top of 2a. So we have to identify what is my a equal to, what is my b equal to, and what is my c equal to. Well, a is in front of the x squared, so it's 1. B is in front of the x, so it's negative 6. And c is our constant, so it's 2. And now we substitute it in. So x is equal to negative 6 plus or minus the square root of negative 6 squared minus 4 times 1 times 2. All over top of 2 times a, which is 2 times 1. All right, then we will go ahead and start simplifying. The negative of a negative 6 is x is then equal to positive 6 plus or minus the square root. Negative 6 squared is 36. Negative 4 times 1 times 2 is negative 8, all over top of 2. 36 minus 8, so x is then equal to 6 plus or minus the square root of 28 over top of 2. We then need to reduce, and let me just draw this little line over here. We then need to reduce the square root of 28. You can use your calculator on a test, but this is going to be 4 times 7. And we look to see, can I take the square root of either of these? Well, the square root of 4 is 2, so it reduces to 2 times the square root of 7. So x is then equal to 6 plus or minus 2 times the square root of 7 over top of 2. Since all of these are divisible by 2, we will reduce each of them by 2, and our final answer is x is equal to 3 plus or minus the square root of 7. All right, some of you guys will want to go ahead and reduce these first here. You cannot divide by 2 until it is able to divide into all 3, which is why we had to wait until after we simplified the radical. And if that radical never simplified, then there's nothing else that you can divide, and that would have been your final answer. All right, let me pause this so I can go ahead and erase this now.